Welcome to another exciting episode of the NIDS View, a weekly show of the National Institute for Deterrence Studies, where we are advancing peace, promoting stability, and helping you to think deterrence. Each week, we discuss and analyze a recent topic and provide insight into how it affects our national deterrence. We hope you enjoy this show.
Welcome back to another great episode of the NIDS View. Of course, I'm Adam Lowther along with Jim Petrosky and Curtis McGiffin. And of course, this week we have a special guest. I'm talking about Jonathan Cefalu, who is the founder of Preamble, which is an AI-focused company that, it's doing some interesting work. And, part of the reason we asked Jonathan to join us on this episode of the NIDS View was because of his expertise in artificial intelligence. He's designed them. He's created some new and interesting stuff. And so we were going to talk about NC3 and artificial intelligence and sort of what are the challenges and how might you use it and what would it take to make that happen. And so who better to have on than Jonathan? So Jonathan, welcome to the NIDS View.
Thank you. It's great to be here. Thank you for having me.
So Curtis and I have written a handful of articles about implementing an artificial intelligence enabled NC3 system. You've written in response to what we've written, and then you've written some other work on it. And so, the three of us have been going back and forth about this. And, Jim does his own work on the implementation and design of artificial intelligence. And so we thought, it'd be really good to sort of get your take as some, sort of a different view, because you have a different view on this than we do. And so let's just sort of kick off the roundtable discussion. Tell us what you see as the big challenges with not necessarily sort of people often think of creating Skynet, that's what AI and NC3 is. And Curtis and I have hopefully explained that it's algorithms performing discrete functions for the purpose of greater accuracy and greater speed. But you're not turning over decision making writ large to AI. But if you were to try to incorporate discrete AI tools into a much broader NC3 system of systems, what do we need to be thinking about? Sort of what are the challenges? How do you see it?
Certainly. So, and I think that one of the areas that AI could help a lot is with, I believe that one of the, you could say, dangers or threats that we need to start taking seriously is the possibility of either essentially false attacks or false flag attacks, basically attacks that are seem like nuclear attacks upon the U.S. but are not really, that they may not have been an attack at all, or they may have been some combination of, let's say, a conventional weapons attack plus a cyber attack with disinformation, things like that. So I think that artificial intelligence one area that it can be applied to help with essentially situational awareness is to detect potential indicators that a perceived attack might not be what it purports to be. So an example of a case where somebody might attempt to conduct sort of a false attack would be against Hawaii, since it's geographically isolated from the rest of the US, that it could be possible, for example, if there was let's say a third party whose intention was to destabilize the world and was trying on purpose to provoke a global war, that one way that they could attempt to do that, for example, would be to make it seem that China or Russia or North Korea had nuked Hawaii. And so they could use a combination of different conventional weapon attacks and cyber weapon attacks and other sorts of disinformation to attempt to make it seem like Hawaii had been nuked when it hadn't really. So that's one way I recommend that AI could be used for beneficial effect, is to help with detecting indicators that what seems to be, let's say, a nuclear strike on Hawaii might actually not be. That, for example, looking at, let's say, the raw data from imaging satellites, raw data from seismic sensors, and other sorts of raw data to try to detect essentially kind of similar to detecting deepfake videos. So that could be applied in situational awareness around attack analysis. That's one area that I recommend AI could be used.
Yeah, so as I think about, and I've read some of the challenges and critiques, and Curtis jump in, is they often make sort of sweeping generalizations. And as I think through the NC3 system, it's 160 plus individual systems that all perform sort of very discrete functions that are then passed along for further analysis with another system. And so I've often wondered how, because this idea that NC3 could be tricked, or it could be spoofed, or we could have false information inserted. I've always wondered, like, be specific. How would that work? Where would that be? Which systems would it be in? Because we have dual phenomenology, we have multiple sensors in both space and on land that we're using, and to me, it seems a lot harder than what I've heard people say they think it might be. So, sort of, Curtis or Jim, did you want to
Yeah.
jump in,
Well,
or?
I would say I'd add to Jonathan's point. The example you give, Jonathan, I think is fascinating. It's not one I thought I considered in this issue when I started working some of this 10 years ago. Our biggest concern of sort of putting NC3 in the cyber world was the biggest fear that there would be some way that a cyber attack, now perhaps an AI attack or an AI induced cyber attack, would either prevent the launch order from being received, or prevent the stop order from being received, right? And so non-repudiation was always the biggest concern, at least in my tenure when I was working this. How do we make sure that the key turners in the field actually believe the order they get, whether it is to launch or to not to launch? But they have to be beyond any doubt that that's a real order. And that to me is one of the challenges here, because as we see deep fakes, as we see more enhanced spoofing and these other methodologies, it almost seems like this digital watch that we're moving to from the old analog watch could be mistake prone, even more so than the analog watch. I don't know. Thoughts?
Mm-hmm. Yes, so I definitely agree with you about that, and I think that so I think another area. So in terms of being able to trust orders that are received and things like that, and you touched on deepfakes, I think another area that relates in general to kind of the human element of NC3 is that I think that we and our adversary nations as well need to be in today's era where audio and video deepfakes are very easy to make. I think us and our adversaries need to be very, very adherent to the strict procedures around communication security. So, as an example of what I think that we need to not do is, I might be telling this story a little bit wrong, but there's an anecdote in Barack Obama's autobiography, and I might be telling the story a little bit wrong, but basically, he was traveling, I believe, in Brazil, I think, and then. Again, forgive me if I get the details wrong, but you guys could look this up later, or listeners could look this up later in his autobiography. But he was traveling in Brazil, and then needed to authorize an airstrike in Syria or something like that. And normally, according to proper procedures, the airstrike authorization order would need to be given through a SCIF facility. However, the SCIF facility that they had on hand in Brazil was having some sort of, I don't know, some connectivity issue. Maybe the antennas were not working or something like that. And so Obama says in his autobiography that he just borrowed the cell phone of an aide and then gave an authorization order just by an unsecured cell phone. and the order was obeyed. And in my mind, first of all, he should not be bragging about that as an autobiography. But second, the military should never, ever accept a authorization order given on an unsecured cell phone line outside of proper chain of command and communication requirements, because it's trivially easy to deepfake the president's voice. So we don't want it where any 14-year-old kid in their basement or whatever could give launch authorization orders
Right.
by using the deepfake on an unauthorized line. So I think that's one thing that's changed in this landscape, that we and opponent militaries need to be way more 100% strict about if an authorization order is given on a cell phone or anything outside of proper chain of command official communication protocols, it should not be accepted.
Yeah, it's a fascinating story. I haven't read that. Unfortunately, I'm going to go look for it now. But there's this. A lot of people will say, "Well, that was for something of a small conventional war in a faraway land, and we would never do that, in our nuclear decision making processes." But I actually argue that as next gen NC3 evolves, there's a lot of effort, I think, to commingle those various comms to be able to use any available means, right, for assured communications, and that would include civilian mechanisms and so forth. Now, whether they would use code or some sort of encryption over these sort of quote unquote open lines, that's beyond my scope, but I would say that there seems to be an interest, I think, in order to develop assured comms. Assured comms means every path available, and that could be a cell phone. And one of the things we wrestled with is, what's the possibility that literally missileers would get texts on their personal phones or on a government phone that said, launch. And because that was the only means left. And, so I think these, in the fog and friction of war, and in the worst of days, that's when you'll have the most challenges. Being able to communicate will be the ultimate challenge, but it's not only being able to communicate, but being able to communicate in a manner in which everybody can believe that it is in fact, in this case, the president. And Jonathan, you even mentioned in your article on War on the Rocks last year, that reminding the readers that president can change, and so maybe we don't know what the labor secretary sounds like now that they're the president, and so these add the secession can add to some of the confusion. And so, how we work through this and put so much faith into this cyber system and sort of how AI can help protect that and looking for those indicators, to me, is fascinating. I hadn't thought of that.
Jim, you've been quiet. What's your take?
So I also, and by the way, Jonathan, I really appreciate you coming on here and talking about this fascinating subject. And I've been working with AI for quite some time, and I've been working in neural nets and genetic algorithms as ways of finding data and sorting through things. And I think that's important for our listeners to know, that there's a great advantage to using the AI for not only decision making, but just for sorting out the chaff from the wheat, so to speak, when you get very mixed signals. Which brings me to back to your article, "Prove It Before You Use It: The Nuclear Retaliation Under Uncertainty" for War on the Rocks last year. That was a fascinating article. I hope our listeners will go out and read that article. I think it's so very good. But in there, and also today, you mentioned this issue of false alarms, and I know you're talking about deep fakes, but there was a good bit of concern about the early warning systems being, increasing our risk. But I'm curious as to how does the AI become a different risk than a human being misinterpreting the data coming from a sensor that points to 200 Soviet aircraft crossing over the North Pole, potentially attacking us with nuclear weapons? How does the AI get faked any more than Curtis McGiffin standing there on watch? What's the difference in that, and why does AI matter here or help us out?
Great question. So I would say that the most interesting example is that AI is, compared to humans, AI is uniquely, or any computer system really, it can basically be backdoored. Or so, of course, like the example that people have seen now is how Israel planted bombs in Hezbollah pagers, right? So that's a recent example of a very dramatic supply chain attack.
Sure.
And that I guess that's really sort of the first recently famous example of a supply chain attack against electronic systems. But I think that in general, supply chain attacks will become more prevalent. But to give a pretty old example, that's there was a lecture given by Ken Thompson. So he was the primary designer and implementer of the original version of the Unix operating system, Ken Thompson. And so in 1984, he was giving a lecture when he received the Turing Award in computer science. And so he gave a lecture about backdoors, and it was called the lecture was called Reflections on Trusting Trust. And so basically, Reflections on Trusting Trust. And he gave the example that if he wanted to, he could basically introduce a backdoor into, he gave the example of putting a backdoor into a software compiler to where basically if you can backdoor the tools that people use to build things, that you can make the backdoor undetectable and self-reproducing. So he basically showed how it would be possible to make a compiler have a backdoor that would essentially, when a human would review the source code for the compiler, the backdoor would not appear there, but the backdoor would be in the compiled output, and it would continue to be there even if the compiler recompiled itself or other variations of this. And that basically, and so what he was getting at is that, he gave this talk in the 80s, but especially now, when we build software, even when we build chips, when we build almost anything, we're using software to do it. And so he was giving the concerning and very, very possible example that about if somebody was really playing the long game. I mean, Israel did the pager attack over the course of, I guess, less than a year. But if someone was really playing the long game, they could have a backdoor that was latent for multiple years and that essentially lingers in software development tools or things like that over a long period of time. And essentially, if you're using software tools to audit your software tools, that was why the talk was called Reflections on Trusting Trust. That if you're using software tools to validate things for the purpose of trust, you don't really have a firm footing to stand on. And then this also connects a little bit to some research that I did a few years ago within Preamble that on the same topic. So this was kind of a case study that we did related to essentially loosely related to autonomous vehicles, but basically we showed how it's possible to make a computer vision classifier that was backdoored in such a way that it would have normal and proper behavior almost all of the time, but then it would purposely misclassify something with one specific visual key or visual indicator. So the example of how we gave of how this would be relevant in an autonomous vehicle case was that we were giving the kind of the story behind of how this could be used by an adversary would be that if somebody hacked, let's say, like Tesla pedestrian recognition software, and if they wanted, let's say, if the Chinese hacked Tesla AI models with the intention of doing some sort of ethnically targeted attacks, so if they wanted to have a higher rate of pedestrian fatalities against a certain ethnicity, that they could make it so that that against a certain ethnicity's visual characteristics, there would be a higher rate of failing to detect the person there. So that's kind of the type of thing that I'm worried about when it comes to AI, especially in nuclear detection, is that AI, if adversaries are able to backdoor AI software, they could put in specific visual keys or visual patterns that would result in non-detection or in false detection. And they'd probably provide both. They'd have patterns that could be used to mask a true launch and patterns of non-nuclear signals, like just, oil refinery flares or something that could be used to create a false impression of a launch. So be able to fake things in both directions.
Yeah, and Jonathan, it's sort of interesting, and I didn't see it in these articles. It's something that most people don't think about. They think about the decision-making process for AI, but all the detection process. But you bring up a very good point. It's something that, as we move forward, and I as an engineer look at it, is AI is a very powerful tool for designing, for example, electronics design, where you can shed, traditional biases that humans put into a circuit or into the design of a system. And you can take those out with AI and perhaps find efficiencies or various, value in designing something completely different that we would never have thought of with AI. I've seen that work quite well. You bring up a good point about that coming into the NC3 system. How do you handle the control of that? And I think of public domain software. I'm a big Mac user. I like a lot of that public domain software for example, Python. I can go out and compile Python, all day long for free because I can go out and use those free Python tools. But someone could be backdooring that. How do you control that in a system as vulnerable as, or as important, I'll say, not vulnerable, as important as NC3 system, and still be efficient and stay ahead of our adversaries who are probably using this to move ahead? I mean, there's sort of a flip side to that.
Very good question. And I would say a very tough question. I think that you're certainly right that having open source tools is very important. I think that unfortunately, in Ken Thompson's talk, kind of part of his point was that in order to truly have the ability to safely audit something, you'd have to essentially redevelop an entire computing infrastructure from scratch. So you'd have to start all over and make an entirely new like processor, chipset, and operating system and everything from the ground up independently in order and to be able to use that to validate other things. I think that's a little bit out of scope, but I think that steps in that direction also are I'm a big supporter of things like the CHIPS Act and efforts to build trusted foundries for semiconductors in the U.S. I think that's another important piece.
Yeah. Let me, Jonathan, let me follow up here before I let Adam take the reign here, because he'll probably close this out. But so recently, there was an effort between the Biden administration and President Xi to sort of get them to sort of commit to not using AI in their nuclear processes, and that we would commit to doing the same. And there was some hope that would come through. And then recently, here a few months ago, President Xi announced that they would not agree to not use AI in their nuclear system, their nuclear enterprise, much less maybe their NC3 and ability to command and control. So I'm wondering if you've given any thought, because I'm interested in your perspective on this as a technical guy rather than some strategist, thinking about so what would China use AI for with regard to their nukes? I mean, would they surrender their decision-making processes and take it out of the CCP's hands and give it to some AI's hands, so to speak? Or are they planning to use it in some other way, perhaps more or less impactful or nefarious? I'm interested in your thoughts on that.
Sure. So essentially, and I followed those negotiations, and essentially the way that I interpret their statements is that, kind of like we've talked about today, that they also see high utility in using AI for situational awareness and especially for understanding the validity and attribution of potential attacks. And I think that's where I agree also that there's a lot of value in that. I don't think that they actually would ever want to turn over launch authority because, I mean, just like we wouldn't either. There's essentially, by turning over launch authority, then you can enable people who don't have much to lose and would want to trigger a nuclear war. I think there are various, especially non-state actors, who would want to actually trigger an all-out nuclear war on purpose. And so, China has plenty of enemies who would love to see the downfall of China and would love to essentially trick China into participating in a global war if China were to surrender launch authority. So I think that's sort of, I think, the nuance, and that's why it's as you mentioned also about getting technologists involved and not just strategists, that's where I think that the future of diplomacy on this topic and making either treaties or at least understandings is that I think it's important to get technologists involved because it's a little bit hard to make treaty statements that are oversimplified, and it's a lot more practical to make ones that go into technical nuance and say, we'll use AI in these ways, but not in these ways. And it's not even so much about it's not even so much like a traditional treaty, but it's just that certain uses of AI would be self-defeating for any country that did them. So it's more about everyone can independently bring their own experts, can understand the topics independently, and will probably come to some of the same conclusions about self-beneficial and self-detrimental ways of using AI.
Interesting. Thank you, Jonathan.
So one of the things
Adam?
that I've often wondered about is, so we're going to build a new NC3 system, and it's either going to be a hard-coded system or it's going to be, a system that integrates artificial intelligence and traditional coding, and so, have some of both. Is there, I would think that if there are opportunities for, artificial intelligence to be backdoored or spoofed or anything like that, then your traditional digital hard-coded system would have those same, we hear about cyber attacks on, gas pipelines and, power producers and just hospital systems and, anything and everything. So we clearly know that those cyber attacks are prevalent. And so I wonder is, are systems that incorporate artificial intelligence any more susceptible to an attack, or is that susceptibility similar, greater, lesser? And that's one of the things that I'm not quite sure of is just, if you're going to have a new system and it's going to have, cyber vulnerabilities potentially, no matter what you do, how do you, increase defense, minimize vulnerability besides, improving coding and, things like that, secure foundries, all sorts of things that we've sort of mentioned already. How do you fix that problem?
Yeah, that's a very good question. I think that, so I guess where I would say that I don't see AI as being uniquely vulnerable, but I think there's a correlation, which is that I think that when you're talking about auditing for backdoors or auditing for supply chain backdoors, essentially the bigger the software, the more you have to audit. And so then a lot of AI models will be very large files, like gigabytes and gigabytes of files, whereas a hard-coded solution might be much smaller in the order of megabytes or even kilobytes. And so then it's much more possible to have extensive human auditing of something that's a smaller amount of code or a smaller amount of model weights. This is sort of a very loose analogy, but something that I think you guys talked about this in one of your episodes around the space-based aspects of NC3 and how when modern small nanometer semiconductors are introduced in space, this is a very loose analogy, but the small nanometer scale transistors are much more vulnerable to EMPs and radiation and things like that. And so, very loose analogy here, but just as I think we shouldn't necessarily, there's not a benefit to replacing larger nanometer transistors with smaller ones. It actually makes them more vulnerable. I think that similarly, moving to more information density in software might make us more vulnerable rather than less. So there are cases where we have better deterrence and better auditability and trustability by having, I guess, fewer bits and fewer transistors that have to be audited and protected and hardened.
Yeah. Jim, did you want to add anything?
Yeah. Well, the other thing is, and I'll see if you can end on this, Jonathan, is when you take a technology off the table that might provide for faster agility in your implementation of various things. And I think NC3, if it takes us 65 years to implement a new NC3 system and put it on the ground because we're so concerned that every step is absolutely foolproof, and then we find new fools, so we have to go back and do this again. what ends up happening is you just continue to fall behind. We've seen that, all the way through the classification system. If you overclassify a system, then you don't get the sharing of information, the innovation, and everything else. So the AI to me is another tool, just like a lock. With every lock comes a key, and with every missing key comes a bolt cutter, and every bolt cutter missing comes a hacksaw. Somebody's going to find a way around it. And if you don't put a lock on a door because someone's going to bring a hacksaw eventually, then you never lock your door. I see the same thing happening with AI, because it's somewhat mysterious right now for a lot of people. How do you think we can get through that mysterious part? I mean, I've recently become very comfortable with AI for helping to write and to analyze data and pull graphs together. There's incredible usage and utility in this. It makes my job faster. And if I can stay ahead of all the other think tanks or all the other technical people or whatever I'm trying to stay ahead of, who cares if they finally catch on to that? I'm already ahead of them. So where do we sort of fit this into our national strategy and our plans for the future, that we don't hamper ourselves with the fear of the unknown?
So let's see. It's a great question. So I think that the biggest thing is simply to make it more known. So the primary area that my company works on is essentially studying the ways that AI could be either backdoored or hacked. And so I think that that's a big thing. Is I think that, of course, this is a little bit of a self-serving, but I do think that the U.S. should put more funding into work like this. So basically ways to understand the ways that AI could be hacked or subverted, because then we can make it more known. That makes it basically something that we can trust more and rely upon in different ways.
Yeah, I think it's fascinating that it sounds to me like it's you take medicine because you've got an illness, and there's side effects to that, and so then you have to take medicine for the side effects, and so this is sort of what we're looking at here. So we want to introduce AI, but because there's vulnerabilities with it, we now have to introduce sort of an AI anecdote, right, to sort of make sure that the AI we want to work works without being interfered with or having these side effects that can be deadly in and of themselves. And so we've got to develop these other options to sort of deal with those challenges that go in there. And I think that is, I think one of our biggest challenges here as we move forward is, as we modernize, how do we keep from inducing new vulnerabilities, much less more vulnerabilities, at the expense of gaining efficiencies? It's probably man's challenge through time, but I would say this is new and unique. The things that we see with AI and drones and the ability to command tens of thousands of drones to all armed and could be very well specifically targeting, as you mentioned in the Tesla example, and things like that. I mean, these quickly become weapons of mass destruction, all in into themselves. And now that we have taken by the automation, you've removed so much of man's manipulation. This may well change the nature of war, much less the character of war. And these are some of the things that I find to be very concerning with regard to AI and military writ large. So those are my closing comments there, Adam. Jonathan, feel free to comment on any of that.
Yeah. And I guess maybe my closing comment would be that I think in general, and as you mentioned, Curtis, that we need, I think CloudStrike is a good example where like trying to add patches on top of patches can make things worse rather than better.
Yes.
So I think in general, I guess my closing thought would be that just because technology is older doesn't mean it's worse. So going back to the example of how do we trust communications, the example of having to send messages over cell phones and stuff like that. So a closing thought as an example of how a very old technology can be beneficial is in cryptography, something that's not very glamorous but works really well is this really old concept called a one-time pad. So people can Google that one-time pad, but it's basically a way to essentially pre-share a code book that you only use once. And so if it's only ever used once, and if it's shared in person in a secure way, then it allows unbreakable communications over any channel. And it's a very old technology, but very reliable. So I think, by analogy, I think that in all parts of NC3 and things like that we should look for technologies that are old and proven, and because they're maybe older, smaller technologies, they're more auditable and trustable.
Fascinating. Thank you. That's awesome.
Unfortunately, we're not going to have a chance to solve this problem today because, of course,
we're not going to solve it.
we're of course out of time, and that seems to be our problem on every podcast, is that we run out of time. So, thanks to you, Curtis, you, Jim, and thanks, of course, to Jonathan for joining us, and for you, the listeners, thanks to you. And if you want to go check out Jonathan's company Preamble, it's on the web, and there's this great thing called Google. It's not an AI, but it's pretty cool too. So go check it out, and check out our website. Curtis is still using the Twitter and posting
Except
articles.
I think we call it X now.
Okay, well, I'll take your word for it. And we're on LinkedIn and everywhere else. You might Snapchat, probably, maybe some Instagram photos of cool stuff. Check us out, and of course, we always want to remind you at the end of every episode to make sure you always think deterrence.
Thank you for listening to the NIDS View. This show is produced under the NIDS Podcasting Network, a division of the National Institute for Deterrence Studies. NIDS is a 501c3 organization dependent upon donations to provide this podcast and bring about awareness of the peacekeeping value of U.S. strength and our national deterrence. You can catch all of our podcasts or provide feedback at thinkdeterrence.com. I would like to thank our producer, Kimberly Charrington, our sponsors, and all the fantastic members of the National Institute for Deterrence Studies for making this podcast possible. Stay tuned next week for another exciting and informative The NIDS View.